Liebl. I'm a staff sales engineer here at Splunk, and I'll be kind of leading the discussion today regarding DSP. I do want to just mention really quickly that you might hear a little extra noise on my end. I'm dealing with a little internet connectivity adversity. Basically, my internet at home went out, and I have to use my phone tethered to my laptop right now in order to do the presentation. So I apologize in advance if there's any difficulties, but hopefully I'll have them under control. All right, and I am sharing my screen here with some slides. If someone could let me know if you can see the slides.
Yep, we can see them.
All right, perfect. So I do want to say, in the course of this presentation, I will be talking about some future features and functionality of DSP, or potentially some future functionality, and I'll also talk about current functionality. I just wanted to make sure that I'm clear that there will be some potentially forward-looking statements, and any purchasing decisions and things like that that you might make, please do it based on current shipping products. So to the best of my ability, where we have new features slated for future releases, I will call that out specifically. But just a little caveat there. So to begin with, from a Splunk standpoint, you might have heard last year that late or in the fall, we came out with our new messaging talking about data to everything. And that data to everything message really came about because of conversations with our customers regarding the challenges that they're facing and the types of business problems they're trying to solve, and how data impacts the decisions that they make in order to run their business. So we heard loud and clear from our customers that they have data coming from different places, going to different places, different types of things they want to do with the data. But the challenge becomes how do you manage that data and make it meaningful and impactful for the business. So there's lots of great new ideas, new devices, new processes that organizations are interested in, but there's some enabling technology that might be required. And this is because turning that real-time data into action is hard. And as Splunk users, you know what it takes in order to get data lifted up off an operating system or pulled out of the cloud, fed into Splunk, and then be able to do some analysis on that. And then finally turning around and doing something actionable with it, it's not trivial. Now, the same types of problems that you face in the traditional Splunk world, that velocity of data, the variety of data, the volume of data, the different users that you have, and security considerations and compliance concerns, all of that still applies when you're wrangling all of this data either inside of Splunk or outside of Splunk. So what we heard loud and clear from customers is they're looking for a way to wrangle this data inside of their organizations, do it as efficiently and performantly as possible, and guarantee that data delivery. And in particular, there were three categories that people expressed an interest in terms of leveraging their data from a streaming standpoint. So not ingest once it's in Splunk, but while that data is in flight, and we're trying to corral that and look at what value we might be able to get out of that data. What we heard loud and clear from users is, first off, real-time transformation of the data. Essentially, in lots of situations, in lots of customer environments, you have chatty log sources that put out error messages, warning messages, info messages, and debug messages. Error and warning is always great. Info and debug, maybe not so much. So how can I trim down those messages and make it more meaningful and impactful for my business? Or similarly, maybe I still want those informational and debug messages, but I need those for maybe compliance purposes or for an investigation, and not necessarily for operational purposes where I want to feed it into Splunk all the time. So what can I do with that data so I can put it somewhere that could be so it could be used in the future? So in addition to kind of that real-time transformation, kind of filtering and routing of data and getting the right stuff out of the data streaming through, we also heard that they really would love to get some continuous real-time insights out of that data. So, one of the things that's a very powerful feature with Splunk Enterprise, but also very expensive, is real-time search, where you're, constantly analyzing all of the data coming through to see whether or not there's a particular condition that's been met that you care about. Well, from a streaming standpoint, this offers another opportunity to do some of that analysis, but from a different perspective, not necessarily from an index perspective, but just doing some raw analysis on that event itself, or potentially doing some calculations and some other manipulations of that data. So can we do things like aggregate net flow counts on a 1-minute window basis or 5-minute window basis, so I don't have to ingest all of that net flow data into something like Splunk, but I can basically pull in some aggregate information on a 1-minute or 5-minute interval, and then save that other net flow or VPC flow log data off for future use for an investigation. Similarly, that enterprise-wide data delivery, we know that Splunk is not the only place that data goes to, and there's good reasons for using other places to store your data, especially if it's not something that's operational that really makes sense to index it. So what can be done to guarantee that this valuable data that's being generated across my organization gets picked up, processed and handled in the appropriate manner, and then guaranteed delivery to the destination that is meaningful for my business? So these were all kind of core tenets for us from a DSP standpoint. So that's where we get into DSP, or data stream processor. Now, the concept here with DSP is we want you to think of DSP like a corral for all of your data. So I have kind of a holding pen where I can send in data, and then based on something that we refer to as a pipeline, I'll process that data, essentially, kind of pull out the horses that or cattle that I care about, and then point it in the appropriate direction so that'll end up where it needs to go, but at the same time operate on that data. So if we look at the diagram on the screen, if we start on that left-hand side of the screen, these are just your usual data sources. Now with DSP, we work with the typical data sources. So you might have data coming from universal forwarders or picked up by heavy forwarders. That data could be fed into DSP. You might have cloud services like you're using AWS. You've got data going into Kinesis, or maybe you've got event hubs in Azure. Those also provide sources for DSP. Any of the typical machine data that you might send to Splunk from any typical sources, we can look at sending that to DSP. Once that data gets into DSP from whatever source, now we have the ability to operate on that data. This is where we have functions that can be executed against your data inside of DSP to perform a number of different things. One is filtering. So we can basically send it, kind of filter out error and warning from informational and debug. We can also normalize the data. We can transform the data. We can format it. We can mask PII. We can do aggregations on values in the data itself. So there's a variety of functions that are available. And in your environment, you would create a pipeline that defines the functions that you want to have operate on your data. And based off of that pipeline, that's how that data gets handled. And I'll show you what that looks like in just a little bit when we get into the demo. But the concept here is I've got a source that will then feed into a pipeline that is a combination of a number of functions. And then once you've operated on that data and all of the processing in the pipeline has been done, the final step in a pipeline is what we refer to as a sink, or basically a destination for that data. So obviously, we'll send that data into Splunk Enterprise so you can get it into an index. Today, with version 1.1 of DSP, we can also send it into Kafka or into Kinesis. And next month, we'll have a new release that will add additional syncs for destinations like S3, SignalFX, and a few others. So those destinations are where, or what we refer to as syncs. Now, the business outcomes that folks are typically interested in from a DSP standpoint are things like organization-wide operational efficiency. Now, it sounds like a lot of buzzwords, but let me give you a couple of examples where this comes into play. The first is simple. I'm just going to take a chatty log source, carve out the valuable bits, and kick the rest of it to the curb. That allows me to reduce the overall amount of data I'm dealing with and just really focus my energies and my efforts on the data that's most impactful for my business. So pretty simple, straightforward. There's a secondary use case here, though, too, or business value, which is inside of DSP, we have a whole concept of role-based access control. So users in DSP have permissions to perform specific actions inside of DSP, and there can also be limitations on what they can do. So one of the exciting aspects of DSP for some of our customers, especially where they have lots of like DevOps folks that might be feeding logs into Splunk for, for typical operational purposes, in those situations, they're interested in DSP because DSP allows them to allow the end user that developer that wants to send logs into Splunk to start streaming that or sending that data into DSP. Once the data is in DSP, they can create the pipeline as to how they would like that data to be handled. This would be things along the lines of what you might normally do with props and transforms for onboarding a new data source, but you would actually be doing it in the context of DSP with a nice graphical editor and the ability to preview in real time based off of your live data what the results of your pipeline would be. And then finally, once they have that pipeline where they want it to be, they can basically go to the administrator and say, hey, my pipeline is good, can you activate it for me? They won't be able to activate the pipeline. So the nice thing here is it's a little more like self-service data onboarding, but with some checks and balances where administrators can look at the pipelines that users have created and then choose whether or not they should be allowed to run based on whatever criteria or policies that you might have in place. So one or a couple of examples there for organizational efficiency or operational efficiency. Immediate business insights. This is really where, maybe for your VPC flow logs or for your net flow data, things where it's super valuable data for investigatory purposes, but something that might not be as meaningful for operating kind of minute by minute. That's where we can look at doing things like running aggregate functions on NetFlow data in order to get some aggregated information and maybe provide that aggregated information back into Splunk for operational purposes, while the underlying raw NetFlow goes into an S3 bucket or something like that. And then finally, compliance and data privacy. This is where in DSP you can just like you can with traditional indexers and props and transforms, you can and heavy forwarders as well. You can mask PII and look at pulling out or redacting data if you need to. Now, I will make a note here that right now we're talking about redaction of PII or the obfuscation of that. We are working on functions that will allow you to hash or encrypt the data with the ability on the back end to potentially decrypt that as well. So that's not something available right now, but it's very high on our priority list for delivery. Now, the typical use cases that we see people approaching DSP for, at least as a starting point, one is just filtering and noise removal. Chatty data sources, I want to reduce the noise, so let me just focus on what matters the most. The second is data routing. How do I send the data to the appropriate place? Maybe I want to create a data lake in S3 so I can have long-term storage for compliance purposes, GDPR, whatever it might be. So routing appropriate data to appropriate data sources is another good one. Data formatting, essentially being able to do props and transforms and things like that against your data while it's in flight, and do field extractions and some more of the typical data wrangling tasks that you might do with, once again, props and transforms and things. And then finally, aggregation. And this is where we can look at coming up with aggregated information based off of data flowing through DSP. So when we're talking about the overall DSP system, let me digress from the slide here for a minute and just kind of try to paint a picture for you if I can. DSP is a different style system or product from Splunk than other solutions that we've provided in the past. DSP is a microservices architecture, so it runs on top of Kubernetes, and there are a variety of different open source components that exist inside of that Kubernetes cluster that makes up your DSP environment. So today we use Kafka internally inside of DSP as the message bus. We are in the process of switching that over to Pulsar because we did acquire Streamlio, and they're the commercial kind of element for Apache Pulsar. So we are making that move, but in any case, both of those are open source components. We also use things like Zookeeper and Minio and Postgres and Flink. So there are a number of components that exist inside of DSP. The good news here is you don't have to worry about any of those individual components, and you don't have to worry about supporting them. So from a DSP standpoint, if a customer purchases DSP, we support the full DSP stack, so the Kafka pods or the Pulsar pods and Flink and so forth. So we fully support the stack. On top of that, the deployment process to deploy a DSP cluster doesn't mean you're artisanally crafting pods to go inside Kubernetes containers. You actually get a single installer for DSP from Splunk. You run that single install to set up kind of the master node for your DSP cluster, or at least the first one. And then you run that installer on second, third, or however many additional nodes you need to run it on, pointing it back at the first. And then they do basically a little Power Rangers assemble and create your DSP cluster. So while there are a lot of moving pieces and there's some complexity behind the scenes, it's not something that you have to worry about as much. What I'm going to go through now is to give you a little peek under the covers to give you an idea as to what that overall system looks like from a conceptual standpoint, but I won't necessarily get into all of the technical details. So from an overall system standpoint, we'll start out with the DSP front end. That's basically where we've got the UI controls. So you've got the canvas for creating pipelines with DSP and all the rest of the configurations and things. And then we also have the abstract syntax tree generator. That's basically where we create that tree for all of the sources, sinks, and functions that are going to be available within DSP. That DSP front end talks to a back-end DSP configuration service. This is where we've got a REST interface to deal with the configuration, and there's also a compiler here for functions and code that's actually executed inside of DSP. And then from here, we get into really the meat of DSP, where we've got Kubernetes acting as kind of the container layer. And then on top of Kubernetes, we have Flink, and we've got Kafka today, soon to be Pulsar. Now, Kafka/Pulsar is the messaging bus. That's basically where the data is being kind of corralled or penned up for the time being. With the Kafka environment, we are sharding your data across all of your DSP nodes in your cluster. Essentially what that means is you will have, if you have a 3-node DSP cluster, any data will be replicated across those 3 nodes, so you can lose one node and you won't lose any of that data. So that's one of those examples of a step that we take in order to guarantee your data delivery. And then once that data is delivered to the location, once we receive that confirmation, it can be removed from the cluster, but we're looking to ensure that it's not removed until it's successfully delivered to the final destination. Now, that's on the messaging side of it, but what's really cool and really important about DSP is not the messaging side, it's the operations or the functions that you can perform on your data. And that's where Flink comes into play, because we use Flink as the environment to basically create the functions that will operate on any of that data flowing through Pulsar or Kafka. That's where today we are creating the sources, sinks, and functions that operate inside of Flink for DSP. We also have an SDK available, and if you go to dev.splunk.com, you can actually find the DSP SDK reference, so you could work on creating your own functions and sources and sinks to add into DSP. And over time, we do expect to be able to create more of a Splunk-based style kind of user community for sources, sinks, and functions in DSP, where our customers and partners can create and share their own sources, sinks, and functions, and it won't just be Splunk developing them and providing them. Now, with the Flink cluster basically performing activities against the Kafka or any of the data in the bus, either Kafka or Pulsar, that bus is basically fed by data producers, and I'll touch on that in just a minute. But after the final processing is done via Flink, basically your pipelines are complete, then the data will get spit out to a Splunk indexer or whatever the actual sink is in DSP where that data is destined for. So if we look at it, once again, maybe a little bit more logically, but with a bit more detail, we've still got our data sources on the left-hand side, and then we've got universal forwarders and heavy forwarders that might be in play for certain data sources. And those are basically going to do a push over to the Splunk to Splunk service. Basically, that's where universal forwarders and heavy forwarders can connect up and send their data into DSP. We also can support REST-based submission of data. So there's a REST interface that you can use to send the data along, as well as we have pull-based connectors, and these are for things like getting data out of an S3 bucket or other locations where a push model isn't necessarily appropriate. So we've got some pull-based connectors that can pull from locations that they need to. And if you have streaming sources, so Kafka, Kinesis, event hubs, things like that, basically that can be fed directly into the Splunk Firehose, basically our stream, which is Kafka today, but it'll soon be Pulsar. And once all of that data is fed into the messaging service and then into that stream processing, the functions in Flink will basically perform any actions that are required against that data and then deliver it out to the appropriate destination. So from a data producer standpoint, what we're talking about here are things like REST clients being able to do a push to the REST API, which then sends the data onto Kafka today, Pulsar, in the next month or so here. For forwarders, either heavy forwarders or universal forwarders, that's also a push to that Splunk to Splunk forwarder service and then into Kafka. For remote data sources, we have a project currently called Large Scale Data Collection, although it'll probably get renamed. But with this, these are the pull-based connectors that we have for remote data sources where push is not an option. And that's where things like S3, we can go into an S3 bucket and look to pull data for you. And finally, that message bus client, Kafka, Kinesis, event hubs, so forth, basically would get fed through that external message bus directly into our stream and then have Flink perform any actions against it or operations against it based on the pipelines you have defined. So let me pause here. There's some more stuff I can go through, and I will get into a demo. But before I do that, because this is a user group, I do want to see if there's any kind of questions or comments. I don't have the chat open, but I'm opening it right now to see if there's any questions. So feel free to chime in. Any questions or comments so far? And I'm just checking the chat right now too.
Yes.
Go ahead. What's your question?
Yeah, the quick question that you said when you can just take the data that you need and you can funnel it off. Like if you're doing an investigation, you want to have all the data and the timestamps. And would you funnel that off to S3?
Yeah, so great question. You know, a typical, as I've been engaging with DSP customers or potential early adopters and early adopters that we do have, customers seem to be evolving towards a model of trying to classify their data in one of three ways. One is the data might be investigatory or compliance related. Basically, it's stuff that they want to have or they have to have, but there's not something that they're going to actively do with it today. And that's where they're looking at sending that data into DSP because it might be intermingled with other stuff too, or there might be stuff they want to get out of that data still. But for the vast majority of that data, they want to pick that up and just turn around with minimal processing and put it into an S3 bucket. And it'll just be saved off in a JSON format in an S3 bucket. And that would be that investigatory or regulatory compliance data. The second category of data is operational data. Now, with that operational data, that's something that you might use to drive your business, your security operations, your IT operations, whatever it might be. And that's something that you absolutely want to get to Splunk as quickly as possible. And then the final category would be actionable data. Essentially, not all events are going to be if I see X, I want to do Y. But in some cases, that very well is the case. So that's where, how can I get that data to Phantom as quickly as possible, or some automation location as quickly as possible to have that worked on. So as it relates to like investigations and kind of the process flow there, what I'm hearing from customers is they're going to route things like NetFlow data, DNS data, all those high volume sources, but things they don't want to ingest all the time into S3. And then as they have an investigation come up that they need to pull that data, the data is going to be written into an S3 bucket. Kind of like with Splunk buckets, you'll be able to see based on the file naming convention, the time span for the data that's written there. You can create at least a little bit of context there. And then as it's needed for investigations, you can basically look to pull data out of S3, ingest it into Splunk one time as part of the investigation, and ideally carve it down just to that time frame that you need for the investigation period. Does that make sense?
Yes, it does. Yeah, if it's noisy, I'm actually driving.
No worries. I'm doing this for my car too. All right. So great question though. Any other questions before I move on here?
Yeah. Hey, Al. This is.
Oh,
I'm sorry. Al. This is Dave Irvin from the Zoom chat. There's a question about how do you make sure that DSP is not a bottleneck?
Yes. So great question. So a couple of different things from a DSP perspective. First off, since DSP is a microservices architecture, you are going to have a DSP cluster. Inside of the DSP cluster, you are not going to have a single pod, for instance, that will be the Splunk to Splunk service. You won't have a single pod that will be the Kafka bus. You'll actually have multiple pods across multiple cluster nodes, and additional pods and additional nodes can be added as needed, assuming resources are available. So the nice thing with DSP is it actually scales pretty linearly in terms of the amount of data that you're feeding. If you add, X number more servers to the DSP cluster, you'll get X amount more throughput with DSP. So it does scale pretty linearly, but the kind of the magic behind the scenes is within DSP, we will spin up additional pods and consume additional resources in order to ensure that your data is being handled kind of as quickly and as efficiently as possible, and we're not going to lose any of it in case you have an outage. Now, there is some performance tuning that we can do for especially large data environments. And when I say especially large, I'm talking about like hundreds of terabytes per day going into DSP. But to give you a little bit of context, in internal testing, we typically use a 5-node DSP cluster That 5-node DSP cluster is made up of 5 servers, each server with 8 CPU cores and 64 gigs of RAM, so basically 8 gigs per core. And if we're doing simple filtering and routing of data going through that 5-node DSP cluster and simply, kicking informational and debug messages to the curb and maybe, sending it to a couple of different places, that 5-node DSP cluster is capable of in excess of 22 terabytes a day of throughput. And as I mentioned earlier, it scales kind of linearly. So, if you need 100 terabytes, we can do, a 25-node DSP cluster, and that will, probably be a little bit of overkill because there is some additional economies of scale, but still, it'll be relatively close. When we're talking about things like aggregation against the data, that is more resource intensive, so that will consume more resources inside of your DSP cluster. And that's where we just need to take a look and keep an eye on resource utilization to make sure that DSP has enough resources. The final thing that I'll say is, in order to ensure that resource availability, when you go to activate a pipeline after you've designed and built your pipeline, when you want to activate it, we'll actually check to make sure you've got adequate resources in your cluster in order to support that, as well as adequate license. But it's at the point when we're looking to start it up that we're going to do that sanity check. And it's not, it wouldn't be something that kind of partway through a running pipeline that you would expect to run out of resources and have things be an issue. It's primarily at kind of the startup process when we'll go through and look to spin up the appropriate number of pods and kind of all of the infrastructure needed for the pipelines that you've identified. So does that make sense? Does that answer the question? Or any further question? That was in chat, so I'll check the chat window here.
Yes, it does. Thank you.
Okay, perfect. All right. Any other questions? I think there was someone else who might have had a question, and just want to make sure we get them all.
Yeah, that was me again. So, so if on the back end I want to put everything into Splunk, does DSP have the option to like set or rewrite metadata, like index, source types and stuff like that?
So within DSP, every event coming into DSP from wherever the source is recognized as a record inside of DSP. And through the process of the pipeline, that gets turned from a DSP record into an HEC event JSON formatted event, because the ingest from DSP to Splunk Enterprise is done over the HTTP event collector. It's just a nice scalable way for us to just blast data at indexers. So in that process of converting the record into an HEC event JSON, you do have functions that allow you to manipulate the fields and metadata and massage that data. When I pull up the demo, I'll give you an example of some of the functions and features that are available. But you do have the ability to operate on those records. Make sense? Any questions there?
Yes, perfect. And one very last question. Should we consider these to be like a black box kind of appliance kind of thing, or do we have enough access to actually tinker with it, the insides?
Yeah, so great question. So first off, DSP is built on top of Kubernetes, and we actually use the Gravity or gravitational installer as our install packager. That means you will have administrative access to your DSP environment, and you will have the ability to use kube control as well as some of the management interfaces available in Gravity if you choose to kind of go poking around. Now, what I will say is we've got lots of customers who have gone down the path of trying to create their own kind of internal streaming solution. You know, we recognize that this is a popular problem that people are facing, and so lots of folks are thinking about what it takes to kind of support that, and how supportable it is to do that in house. So we don't want people to think of DSP so much as a black box, because you can see the infrastructure and you can see what's happening, but we'd rather have you think about it like a pre-canned collection of tools or functions, so that you don't have to reinvent the wheel, and we provide great infrastructure that you can then build on. So, you know, the way I would think about it is, instead of having to kind of build out Kafka and then figure out how to operate on that data and everything else, we've done the blocking and tackling to put that infrastructure in place, and then we've created a handful of sources, sinks, and functions to start. And then that is really kind of the building blocks that we can start kind of building off of. But it is meant to be completely open and extensible, and not so much of a black box. You just don't have to worry about all of the stuff inside of DSP, because we'll support you with that, but you'll be able to see it. So hopefully that makes sense.
Yes, very much so. Thanks, Al.
Okay, perfect. Great. All right. So great questions. So one final check to see if there's any more questions. Otherwise, I'll kind of move on to some more slides here, and we'll get into the demo shortly. Going once. All right. So, you know, why don't I do this as a matter of fact? I'm just going to change here. I'm actually going to do a quick DSP demo just to change it up before I go back to the slide. So hopefully you can see my screen. I'm sharing the DSP UI. Are you able to see that?
Yeah, we can see it. Thank you, Al.
Okay, perfect. I'm just checking. I'm a little paranoid since I am in my car tethered to my phone. All right, so we're looking at DSP right now. With DSP, there are a couple of things that I want to drive home. First off, the concepts. Sources, where data comes from. Functions, what I can do to operate against that data. And sinks, or destinations, where I want to send the data to. That is all accomplished in the context of a pipeline. So this is just a welcome page showing us some resources and recently created pipelines. I'm going to start out by just going to build pipeline. And from here, you'll notice I have an option to choose a data source or choose my template. Now, these things, and by the way, I'm using a development environment that's shared with other folks. So you will see some things here that might not be kind of normal as part of the standard product. So this is really just for demo purposes. But the data sources allow you to choose a source function to start with and then build your pipeline from there. And this is where we can do things like get data from S3 or from Kafka or read from the Splunk Firehose or Azure Monitor Metrics. And if I wanted to create a pipeline, for example, and we'll just try like the S3 connector. As I click on that, it adds this function here, and let me let me move this real quick. Bear with me for a moment. I'm trying to get a little more screen real estate. Come on. All right. Sorry. All right, hold on. I apologize for the screen real estate here. It's less than ideal. Sorry, I'm just trying to see if I can't resize the screen here.
Sounds like a feature request.
All right. This might be a byproduct here of, you know what, actually, I've got one other idea. Bear with me. We'll do this the old-fashioned way. I'll just change my screen resolution. Apologize for this one. And no, no love on that. All right, so this will be a feature request, unfortunately. So what you won't be able to see down here is it's at the very bottom of the screen. Is basically I have a connection ID for the S3 connector, and then with that connection ID, I could basically say I want to create a new connection. So okay, looks like it's not going to agree with me right now, but basically this is where I would provide the connection details for S3. Let me just check comments here real quick or the chat. The button's on the right-hand side here. Ah, thank you. All right. Yep. So basically, with having my connector set up, and I'll just reuse this S3Conf demo. We won't pull data from here. I've got other pipelines that are live and running, but I can click on the plus sign next to that source, and now I get a list of functions that I can use. And let me kind of scroll through here very quickly. So we have things like line breaking, timestamp extraction, aggregate with trigger, some batch processing capabilities. We can look at doing breaking events, some deserialization, eval commands, extract timestamps, fields for promoting fields. Any of the types of things that you might want to do, those are things that are available here as part of the functions. Now, with any of these, I can basically say, okay, I'll take a particular function and add it in, and you'll see it will just get added into the canvas. And then down here at the bottom, I basically now have my function available. So I have an eval command. Now, let me digress on this for just a moment. DSP 1.0 is what we're looking at right now. DSP 1.1 will be released next month, basically in early May. Now, DSP 1.0, the language that's used for the functions is what we refer to as DSL, or a domain-specific language. It's essentially Go underneath the covers. That's not the most user-friendly thing in the world for our customers, and we understand that because people are typically used to using SPL. So one of the key new things that we're doing with 1.1 that will be released next month is converting from using DSL, or that domain-specific language, to SPL v2, which is like SPL, but it's the next generation. And the nice thing here is what you use to configure searches and pipelines inside of DSP, that SPL will be able to be used in Splunk Enterprise as well, and applied to your indexes and things. So we're standardizing on that common language. Given that fact for right now, I'm not going to go through and worry about spending a ton of time on the functions because the syntax is kind of ugly and basically does get better with the next release. But I just want you to be aware that the function exists here so that you have the ability to do some of that customization and configuration. And I'll show you what that looks like in just a moment. But any questions on that from kind of a DSL and SPL standpoint? All right, no question. All right, so let me pull up another pipeline here that had been previously used, and let me make this a little bit smaller here. All right, so in this case, we're actually looking at a pipeline that's been created for Cisco ASA source type identification. Basically, typical, I've got a bunch of data coming in, I want to do some source type assignment. So if we just walk through the pipeline, and you'll see here that this is an active pipeline. We don't have a ton of Cisco data coming through, unfortunately, so we won't see that, but we can see that there's low latency and just not a lot of data hitting this particular source right now, or this particular, the source. So it's coming in from the REST interface. When we come over here to eval, you'll notice here that we're basically taking the body of the DSP record, so that's essentially the event, and casting that as a string. And what this allows us to do is then start to work against the body of that message. And it's a little difficult to see here. Let me see if I can make it a little bit bigger. You'll see here for the set source type, we'll show you along the sides here the different input fields, and then we have the output fields, and then you've got the actual rules or the field that you're kind of processing against. So let me shrink this guy down, and let me go on here. So essentially what we're looking here is to check to see if there's that Cisco ASA source type. So now we've got aware, where we've got if the source type is Cisco ASA, then we'll go on down the pipeline, extract the timestamp, and then write it out to Splunk. Alternatively, you notice here that we've got a branch that will take the data down to another function, and this is where if the source type is not Cisco ASA, then we'll come down here and we'll see if it's null, and that's basically we'll write it to a catch-all bucket just for audit D. So this is an example of just a simple pipeline that does some different manipulations. Let me go back and show you one more thing. I'm just going to discard these changes for the moment. We do have a concept with pipelines of templates as well. Now, with DSP, heavy forwarders and universal forwarders don't go away. You'll still have a variety of mechanisms for kind of getting data from somewhere and sending it. But within DSP, what we want to do is give you the ability to replicate some of that TA capability as we can do it. So where we have templates, a template is kind of like a TA or a technical add-on for Splunk Enterprise. This is where we have kind of the definition of the source, the functions, and the sink for a typical use case, and then you can use that and kind of clean it up as you see fit. Right now, we have a limited number of templates created for you, and you can create your own templates. The goal is, we have hundreds of TAs in Splunk Base. We won't necessarily have one-to-one parity between TAs in Splunk Base and templates in DSP, but our goal is to try to get to that point over time. So this is where if there's common data handling requirements for certain source types and things, over time we'll look to populate kind of that list of templates for best practices on how to handle that data. So that was a very quick kind of demo of DSP. Let me jump back into the slides and finish up with a few things here. All right. So why is it that people are looking at Splunk and DSP for stream processing? The out-of-the-box stream processing, lots of customers have been working on, kind of internal projects trying to create their own streaming offerings. It can be very tricky, and there are lots of moving pieces. We recognize that given the variety of open source components that make up DSP. So we can provide more of a turnkey solution that allows you to do the operations you want on the data without having to kind of build all that infrastructure yourself. Now, another reason why we're seeing people interested would be that how it complements the Splunk portfolio, allows you to kind of do different data handling based on different use cases, investigatory security data or IT data, send that to S3 or long-term storage and so forth. So that is, just being able to support different use cases from that streaming functionality standpoint. Custom functions is also an important one. I just want to digress here and give you an example. One of our DSP customers is an online financial organization. They do millions of transactions per day. And in particular, they are concerned about fraudulent transactions and looking to try to get an early warning of when they might have fraudulent activity. So we worked with them through the evaluation process to help them create a custom machine learning function that runs in DSP that helps them identify potentially fraudulent transactions in the stream. So we're talking about millisecond level latency here for the identification of a potential fraud versus however long it might take for that data to finally get ingested into Splunk and have a search run against it to identify that there could be some fraud. So a tremendous benefit for them and a cool use case for us in terms of leveraging machine learning against the stream. And then finally, DSP is an important part of our data to everything platform. And we recognize that data, it needs to be in different places based on the decisions that you need to make against that data. So we want to be able to take it wherever you might have it coming in and be able to send it wherever you might want to send it to. With that said, I'm not going to worry so much about the use case example here. I want to talk about what it would take to try to get started. 1.0 of DSP is a little bit more limited in terms of sources and sinks because it was the first release. You can see the supported data sources today: Kafka, Kinesis, S3, Universal Forwarders, CloudTrail, Event Hubs. We are adding more and more sources to DSP, so we will have an HTTP event collector source for DSP with the next release. We are adding a syslog source, although I don't know if that'll be in the next release or following. We'll look to continue to add that based or augment those sources based on customer demand. In terms of destinations, 1.0 was a little bit more limited, just Splunk along with Kafka and Kinesis. 1.1 will add S3, we'll add SignalFX, and a variety of other destinations and some other options like Kafka with Kerberos authentication and so forth. So if you're interested in getting started, if you have sources and destinations in terms of what you want to do, where your data is coming from, where you want to send it to, that are on the supported list or on the new list that will come out with DSP 1.1, then that very well could be a good use case for DSP and something would be worth talking to one of my colleagues here at Splunk about. So let me stop there. I know I've kind of covered a fair amount and went through a variety of different details, but just wanted to see if there's any more questions given kind of the time and if there's anything else I can do to help you better understand DSP.
I got one more question.
Go for it.
Is there or will there be an API to this? Like, if you want to use Ansible or anything else to script out pipelines and stuff like that?
So, great question. Right now, with DSP, there is a REST interface that DSP uses for the UI front end. And that REST interface is something that is also available, or you can make it available for external usage. And if you go to dev.splunk.com, we have kind of the SDK and the REST interface for DSP fully documented there.
Sounds good. Thanks.
Yep. All right. Other questions, and if there's no other questions, I'd also just love to hear if this was kind of on target for what you're looking for, or if the content kind of was off the mark. Just love to hear any feedback as to the types of things folks like yourselves are interested in.
Oh, that was good. Straight to the point. Good overview.
All right. Great. Thank you. All right. Any questions? All right. Well, go right ahead.
All right, thanks, Al. We really appreciate you presenting, especially with the challenges that you had with your internet connection, kind of going above and beyond. So that's great. I really do appreciate all the information and taking the time out to present. So, Sean, I'll let you kind of wrap things up.
All right. Well, everyone, thank you for taking an hour out of your day to come and join us. We'll reiterate, if you had any questions for Al, you can always email him at aliebl@splunk.com, or if you had questions for Dave, d@splunk.com, or if you have any questions for me at sruthier@blizzard.com. We have the Slack channel, just to kind of remind everyone. It's hashtag SoCal_user group. And our next meeting is Tuesday, May 26th. So thank you, everyone, and I hope you have a great month and week and day.
Thank you.
Thanks so much.
Bye, guys. Thanks, Sean.
Thanks.